Note card 4, evaluate f of x when x is equal to some number. So we have an equation, example, and this is what f of x is. It says f of x is equal to x squared minus 4x plus 5. Now there's two ways you can do this when you're given a simple number to plug in for x. You can use your skills in being able to simplify an expression using PEMDAS, or you can use your graphing calculator. I'll show you both. If we have f of x is equal to x squared minus 4x plus 5, then f of 3, what I would like to tell you to do is rewrite the function, but everywhere you see an x, put a set of parentheses. So x squared minus 4x plus 5. We want to know what f of 3 is. So what you want to do is, whatever x is over here, simply plug it in to each set of parentheses that you made. Now you have an expression here. Once you have it plugged in, you are only worried about what's to the right of the equal sign. Once you have whatever x is, this value over here in parentheses, once you have this plugged in, you can essentially, you can forget about it. Once it's plugged in, you can forget about that and just simplify this expression. But you have to use PEMDAS. Parentheses, exponents, multiplication, and division. Remember, when it's talking about parentheses, it's talking about something inside parentheses, some operation within the parentheses, such as, here's an example, sorry, my battery's running out of my pen. 4 minus 3 or something like that in parentheses. You would have to do the 4 minus 3 first in parentheses. Here, parentheses, I only used these because I was trying to come up with an easy way to get you to see how to plug this 3 inside for each x. But what we do have is an exponent here, so that has to be done first, and 3 squared is 9. So what I'll do is I'll rewrite that 9. I'll rewrite the whole thing like this. So 3 squared is 9. So I have 9 minus 4 times 3 plus 5. So in PEMDAS it says parentheses, and then I have to do exponents. Next I have multiplication and division from left to right. So I only have one set of multiplication here. So I have negative 4 or minus 4 times 3, which is minus 12. So what I now have is 9 minus 12 plus 5. Now all I have is addition and subtraction, so I just do that from left to right. 9 minus 12 is negative 3. Negative 3 plus 5 is positive 2. That is my answer. You should already be able to do that being in pre-calculus. That should be a very simple review right there. So what we would probably do most of the time in pre-cal is use our calculator. My function is x squared minus 4x plus 5. So if I plug that in, now I can find any value over here, especially when I have a whole number. Well, with these first two examples, it'll work. Right here, it won't work because I have a variable inside. That's a different story. I'll show you that in a second. But if I want to find out what f of negative 1 is, since that's, well, it's not a whole number, it's an integer, but it's not a decimal. So all I have to do is look at my table. If I hit second, graph, if I can scroll and find when x is negative 1, there's my answer. When x is negative 1, y is 10. When x is, that's an A. I was thinking it was a 0, so I can't do that one here. But if I wanted to go back to my previous example, if I wanted to know when x is 3, it's right here. It's 2. Well, I figured that out the hard way. So that's a way you can use a calculator. Another way you could have found that in the calculator is you could have did second trace, which is calculate, and find the value, and it'll actually graph the function for you, and it'll say x equals. Well, I want to know when x is equal to 3. Hit enter, and there it is. Y is equal to 2. So there's 3 ways you can do that using the calculator when you're just simply entering in a number. These next 2 examples are a little different. We're going to be entering in a variable. So f of a is what I want to find out. So again, I use my trick I used before. I'll put a set of parentheses everywhere I have an x. So I have x squared minus 4x plus 5. Now I want to plug in an a everywhere I had an x, so I just simply plug that in, a and a. And all I've essentially done here is change my variable from x to a. I can't simplify a squared, so that's simply a squared. I can't simplify 4 times a. I don't know what a is, so it's still minus 4 times a, which is 4a, and then plus 5. And there's my answer. This next one's getting a little more complicated, but still, I'm going to plug this in, so I'm going to keep my same technique that I was using. Write a set of parentheses everywhere you have an x, and I'm going to make my parentheses a little bit further apart because I have an expression that I'm plugging in. Minus 4 times x plus 5. Now I'm going to plug in this a minus 2. Now I need to simplify this. Now this is where you should already in pre-calculus be able to do what I'm about to do. You should be able to do it without hesitation. If you can't, we've got some work to do. You should know right here, some of you are going to want to distribute this power inside. You cannot do that. What a minus 2, the difference, when I say difference, I mean that because of the minus sign. When you have the difference inside a set of parentheses and that being raised to the power of 2, I'm going to start down here rewriting it. What I really have is a minus 2 times a minus 2. Here, I do not have a power. So I can simply distribute this 4, this whole number, outside. So this becomes minus 4 times a is minus 4a. Minus 4 times minus 2 is plus 8. And then I have my plus 5 left out here. What I have to do here is I need to FOIL these. There are some rules you can use. Some of you FOIL, some of you do box method. I prefer the FOIL method. Foiling, if you recall, you have first, outside, inside, last. So my first 2 terms multiplied together. A times a is a squared. Now my outside 2 terms, that's a times minus 2, which is minus 2a. Now my inside terms, minus 2 times a is minus 2a. Notice I'm putting my like terms in little vertical columns here. And my last 2 terms, minus 2 times minus 2 is a plus 4. Now I can combine all this. I have a squared minus 2a plus minus 2a, or minus 2a minus 2a, same operation, is minus 4a. Then I have plus 4. Now I have to go back up here because I cannot forget this. All I've done, all this was right here was foiling. So I have a minus 4a, a plus 8, and I have a plus 5. The last thing that I need to do is combine my like terms. Here's the way I like to do that. Start with the highest powers. I have an a squared right there. I have no more a squareds. So a squared is in my answer. There it goes. I can mark that one out. I'm done with it. Next highest power are my a terms. I have a minus 4a there, I have a minus 4a there. Minus 4a is minus 8a. I'm finished with my a's. I can mark those out. Now I'm left with my constants. I have a plus 4, plus 8, plus 5. Well, it should be pretty easy. 4 plus 8 is 12, plus 5 is 17, plus 17. Here is my simplified answer, a squared minus 8a plus 17. Some of you, if we go back up to where I foiled, I might have lost some of you here. If I did, we've got some work we need to do. Really quick, if I have a minus 2 times a minus 2, could have also done the box method. I have a 2 term by 2 term, so I'm going to need a box with 4 squares so I can have a 2 by 2. So that's a minus 2, and then multiply the appropriate boxes. A times a squared. A times minus 2, minus 2a. Minus 2 times a is minus 2a. Minus 2 times minus 2 is positive 4. Combine like terms. A squared minus 4a plus 4. That's how I could have multiplied those two out. Okay, continuing on with the note card. To find f of 3 on a graph is very easy. Okay, here's how it works. If I want to know what f of 3 is, what I do is remember that inside here is the x value. So I come over thought I had a dotted line there, I don't. I come over to where x is 3. So 1, 2, 3, and I want to go straight up where it meets the line. And then to find out what y is when x is 3, I go straight over. And I see that x, when x is 3, y is 1, 2, 3, 4, 5. That's how we get 5 right there. Hopefully that was easy. We'll have to work on that maybe. Now to find in a table, if we want to know what f of 4 is, very simple. Remember, what's inside the parentheses by the f is the x value. Well, when x is 4, see it? When x is 4 right there, there's x when it's 4. Well, what's y when x is 4? Well, it's negative 6.